Now we are going to see the experiment of step-up and step-down MOSFET based choppers. So the aim of the experiment is to construct a step-down and step-up MOSFET based choppers and draw its output response waveforms. So the apparatus required is step-up and step-down MOSFET based chopper kit, then CRO of 20 MHz and some patch cords. So the procedure for step-up chopper and step-down chopper is initially all the switches in the off position and initially keep the duty cycle in a minimum position. Then connect some banana connector of 24-volt DC source to 24-volt DC output and input. Then connect the driver pulse, switch on the main supply, check the test point waveforms with respect to ground. Then vary the duty cycle and tabulate the T on, T off and the output voltage. Then trace the waveform for V0, that is output voltage versus your output current, and then draw the graph for output voltage versus your duty cycle. So the formula is given, that is duty ratio by for step up chopper and step down chopper. So using this formula, calculator readings, that is for theoretical and practical. So theoretical we not formula, that by using the above formula we can calculate theoretical. So practical, from the CRO we can write the V naught. So for both the step up and step up chopper. So these are the model graph for step down chopper and step up chopper. So here it is the circuit diagram for a step up chopper and step down chopper. So chopper is a static device in which the chopper is a device which convert a variable DC voltage which is obtained from a constant voltage source. That is, a fixed DC source is converted into a variable DC source. So it is also known as a DC to DC converter. So once fixed DC supply voltage is converted into a variable DC supply voltage, so it is most widely used for the motor control. So the choppers are of two types. So it is called a step up chopper and step down chopper. So step down chopper is nothing but your output voltage is less than your input voltage. But in a step up chopper, the output voltage will be more than your input voltage. So in that we can see that in a step down chopper, so we are having a circuit diagram. So in the step down chopper we are having that input supply of fixed DC supply of 0 to 20 volt. Then here it is your chopper. Then you are having one diode with a resistance and then capacitor, then on inductance with a load you are having a resistive load. So in this the thyristor in the circuit it acts like a switch. So we are using here, it is will be acting like a switch. So when a thyristor is on, the supply voltage appears across the load. So in thyristor when it is on, it will the supply voltage will appear across the load. When the thyristor is off, the voltage across the load will be a zero. So that chopper, so both are here also having the same method. So when DC supply is given, so by using the chopper we can given the supply voltage to the load. When it switches open, then the supply will be off across the load. So this is so this in this chopper, this switch will be acting like a closing and open operation. This chopper can be controlled by two methods. That is, the output DC voltage can be varied by the following methods to control it. So it having a pulse width modulation control or a constant frequency operation, or otherwise the second one controlling method is a variable frequency control. So in the pulse width modulation, by varying a T on, so T on is varied keeping a chopping frequency F as a chopping period T as a constant. So the output voltage is varied by varying your on time. So T on is varied by keeping a chopping frequency F as a chopping period T then the constant, and then output voltage is varied by varying the T on, that is the time or T on. So by varying the T on, we can calculate your output voltage. Then by variable, this is the for your fixed frequency control. For variable frequency control, your chopping frequency f is varied by keeping either T on or T off as a constant. To obtain the full output voltage range, the frequency has to be varied over a wide range. So this is the circuit kit. So we can see here, this is the MOSFET based chopper kit. So in both the step up and step down chopper characteristics can be performed both in the same kit. So by using the RPS, we are giving a supply and with the connections from that. So first itself, so first half will be a step up chopper and second half will be a step down chopper connection. So here that connections were given, and with the help of the meter we can see the voltage, how that input supply is given and how the voltage is stepped down. So we are giving a 15 volt input, but with the output we are obtaining only a 10 volt. So it is a step down chopper. So here the output is step down, and the corresponding output waveforms for that. By controlling the frequency, the output waveforms are shown in the CRO. Then here by seeing it, to obtain the full output voltage range and frequency has to be varied over a wide range. So this method produces a harmonics in the output for a large T of load current and may it become discontinuous. So these are the waveforms from the CRO by varying the different input voltage and their output voltage. So but from the tabular column, for we can fix a constant voltage and different time on and T of T seconds with the help of the duty ratio formula. So here for step up chopper, K is equal to T on by T and V naught equal to Vs into 1 minus K. Then as well as for a step down chopper, the duty ratio formula is K is equal to T on by T, then V naught equal to K into Vs. By using with the help of these formulas, we can calculate the theoretical values, and then from the practical we can obtain the values from the CRO. So at last we can draw the model graph. With the help of the model graph, we plot the graph with the help of the above tabulation readings. So thus the output response of the step down and step up Mosfet based choppers were drawn. Thank you.